Good morning and peace be with you. Welcome to our class today. I am Amshe and I will be your teacher for today's episode. I hope you're having a wonderful day. Before we start, make sure you have your self-learning module, pen and paper to write your solutions later. So are you ready? Let's start! From our previous lesson, we learned about determining the center and the radius of the circle given its equation and vice versa. Today, get ready for another topic that we will be discussed together. For today's lesson, we're going to discuss graphing and solving problems involving circles. In graphing of circle, we will be discussing how to graph manually on the coordinate plane or by using GeoGebra app. Now, let us identify the steps in graphing the circle on the coordinate plane manually. First, determine the coordinates of the center and the radius. Second, if the equation of the circle is in a general form, transform it into standard form quantity x minus h squared plus quantity y minus k squared equals r squared. If the center of the circle is hk, or x squared plus y squared equals r squared if the center of the circle is at origin or 0, 0. To graph the circle, place the point of the compass to the center and count the units to represent radius. Swing the compass to draw the circle. Now, let's discuss some examples in graphing and solving problems involving circle. Example 1. Find the center and the radius of the circle x squared plus y squared equals 36. Then draw its graph. In this problem, we need to determine the center and the radius from the given equation and draw its graph. The equation of the circle x squared plus y squared equals 36 has its center at the origin. Hence, it can be transformed to the form x squared plus y squared equals r squared. The circle has its center at 0, 0 and its radius is 6 units. Graph the circle, here are the steps. Draw the x and y axis. Label the axes with the positive and negative numbers. Plot the center at 0, 0 or origin. Count 6 units to the right and plot another point. Place the point of the compass at 0, 0 and on the point on the circle and swing it. Now that you know how to graph manually, I'll introduce you to an app that will help you to draw the graph of the circle easily. The app we're going to use is the GeoGebra app. First, you need to download the app from Google Play Store or App Store to your mobile phone. Look for GeoGebra Classic, download and install it. Now, let's proceed with example 2. This time, we'll be using the GeoGebra app to graph the circle. Determine the center and the radius of the circle quantity x minus 2 squared plus quantity y minus 4 squared equals 25 and draw its graph. For our solution, quantity x minus 2 squared plus quantity y minus 4 squared equals 25 can be written as quantity x minus 2 squared plus quantity y minus k squared equals r squared. Then, quantity x minus 2 squared plus quantity y minus 4 squared equals 5 squared. The center of the circle is at 2, 4 and its radius is 5 units. So here are the steps in graphing the equation of the circle in standard form using the GeoGebra app. First, plot the center using the point tool. Then count units from the center based on the length of the radius and plant the point. Look for the circle tool, choose circle with center and click the 2 points. In this example, a circle has its center at 2, 4 and a radius of 5 units. Once you have opened the app, click the button below and click the point tool and plot 2, 4 as the center. Count 5 units to the right to place the other point. After that, look for the circles tool to choose circle with center and it will command to select the center and the point on the circle. Just click them, then a circle will appear on the screen. To view the equation, look for the algebra button, then you will see the equation of the circle quantity x minus 2 squared plus quantity y minus 4 squared equals 25. See, you can easily graph using your mobile phone. For our next example, let's solve this given problem. A typical Wi-Fi router can efficiently cover space up to 46 meters radius. And when you move further away, the signal gets weaker. Suppose that the router is located at 0, 0 on the coordinate plane whose units represent meters and you are located at point 4035, will you be able to connect to the Wi-Fi? For our solution, determine first the center and the radius. From the equation, the center of the circle is at 0, 0 and the radius is 46 meters. To graph, using the GeoGebra app, click the button below and click the point tool and plot 0, 0 as the center. Count 46 to the right to place the other point. Minimize the graphic view so that you can see the points. After that, look for the circle tool. Choose circle with center and it will command to select the center and the point. Just click them, then a circle will appear at the graphic view. Since we already constructed the graph, we can answer now the questions in the problem. Will you be able to connect to the Wi-Fi if your location is at 4035? Locate point 4035 and observe. We can see that the coordinate 4035 is the outside the circular area. The answer to our problem is no. You will not be able to connect to the Wi-Fi router efficiently. And there you have it. That is our lesson for today. I hope you were able to graph the circle and apply the GeoGebra app in graphing circle on the coordinate plane. Now that we are nearing the end of the lesson, prepare your pen and paper, graphing paper, compass, ruler, or GeoGebra app to do some activities. For our activity, we are going to solve and graph the following problem. You may use the coordinate plane or GeoGebra app in graphing each equation. Number 1. Find the center and the radius of the circle x squared plus y squared equals 49. Show it graphs. Determine the center and the radius given the equation x minus 5 squared plus y minus 6 squared equals 81 and draw its graph. And there you have it, class. I hope you have answered our activities correctly. But if you find it difficult to understand, you may play this video again. And that's all for today. I hope you have learned a lot from this session. Again, I am Sherilyn Alcantara. your math teacher for today's visual lesson. Keep safe and see you in the next episode. Thank you.